Hello, everybody. Okay, so this is the third part here, and we've talked about measuring angles in a triangle and in a circle. We've talked about different angle measuring system, degrees and radians, and we talked about a little bit about how they relate to each other and how we can convert from one to the other, including those two very important formulas. All right, now the third are some application problems. And number one, okay, there are two kinds of application problems we're going to leave you with today. Okay, the first one, well, they both have to do with circles, as you might imagine. So here's my super handy dandy circle here, just like that. Okay, so remember, we're going to measure angles from there, right? That's from our horizontal zero angle measurement. So one of the things we want to be able to do is to be able to calculate on something on a circle called the arc length. And we talked about how angle measurements like radians or degrees are like ratios, right? They're not really absolute measurements. So like 10 degrees on a small circle, 2 points that are 10 degrees on the surface of a small circle are actually further apart if you expand that circle out, right? They'll still be 10 degrees of arc away from each other out of the 360 for the whole circle, but, physically, in terms of an absolute distance, if you measured it in inches or something, they'd be further apart from each other, okay? So it turns out that the distance let's call it the linear distance on the arc, the outside of the circle, the outside or the arc of the circle, that's called the arc length. Okay? So whenever we talk about arc length, that's going to be a distance, like inches or feet or miles or something. Okay? And then, so how do we know how much it is? Well, it turns out that there's formulas so we've got some formulas here to calculate that, and what you're going to need to know to calculate an arc length is you're going to need to know the angle, which I'm going to label. You see that little funny symbol there? It looks like a circle with a slash through the middle of it. That is the Greek letter theta. And that is, we could use X or Z or A or any other variable name, letter name for the variable, but just sort of by convention in trig, and in trig applications, angle measures are often designated using this Greek letter theta. Okay? All right, so let's say that the angle is going to be some number theta. The angle measure is going to be some measure theta in either radians or degrees, and then the radius is going to be some number r, right? Okay, measured in distance units like inches or feet or something like that. Now, how do we measure the arc length if we know those? Well, let's get a specific example here. Let's say we've got a circle here, right? And I happen to know that this is 10 centimeters, and I happen to know that the angle there is, let's say 30 degrees. If this is 10 centimeters, then how many centimeters is it along? How many centimeters is this 30-degree gap going to be on the circle? If you're a little person there and you have to actually, walk that distance, right? Okay, so think about it this way. The entire circle all the way around is 360 degrees, right? So the entire circumference of the circle would be, if you remember, your circumference formula is 2 pi r, right? So the entire circumference in terms of centimeters would be 2 pi r. That would be if we went all 360 degrees around. Well, we're only going a proportion of it. And that proportion is equal to whatever proportion 30 is 30 degrees is out of the 360. So in other words, whatever fraction the angle is out of the entire 360 degrees, that would be proportional to that same fraction is the fraction that the arc length is of the entire arc 2 pi r, right? The entire distance around. So anyway, so that would be for our concrete example here, right? We would just go ahead and, sort of multiply that out to get it, right? I'd probably leave the pi in it. Okay, so this would be 330 over 360, which, as it happens, see, 3 divided by 36, that's 12. As it happens, that's 1 over 12, if we reduce that, times 2 times pi times 10, right? So that's going to give us 20 pi over 12. And that's 5 pi over 3 centimeters in terms of that. And if we want to have, that's kind of a weird looking number. If we want to know what that is in more familiar terms, it'd be 5 times shift pi, all right, divided by 3, which is about, so the arc length is about 5.24 centimeters, is what that would be. Okay? So now, it turns out, so that is going to be one of our arc length formulas here, right? And I'm going to write it right here. Then on the last page, I'll put them all in one place. If your angle is measured in degrees, like 30 degrees, so in degrees, okay, the arc length is equal to theta the angle divided by 360 times 2 pi r the radius, right? Now it turns out that if we're measuring this, instead of measuring the angle in degrees, what if we measure it in radians? Well, it turns out that 30 degrees, if you convert it, turns out to be pi over 6 radians. And the entire arc is 2 pi. Instead of being, the entire arc is still 2 pi r, right? So it's going to be the arc in radians. Okay, so the arc length in radians is going to be the angle pi over 6 divided by 2 pi, because it's the same thing, that pi over 6 is proportional to the entire radian arc around, which is 2 pi, times 2 pi r, right? Well, notice something convenient happens there. Do you notice that the 2 pi cancels out, right? So, the arc length would just be pi over 6 times r the radius, which is 10, right? Well, that's 10 pi over 6, which is still 5 pi over 3, which is still 5.4 centimeters, right? So either way, we end up with 5.4. But you notice here that this formula here was a lot simpler because the 2 pi canceled out. So if we've got our angle, if you have to figure out the arc length, and you're given the angle in radians, then you only have to use this formula. The arc length is equal to theta times r. And this is in radians. Theta in radians, and the first one was theta in degrees. And so there's no dividing by 360. You don't have to mess with the 2 pi. It's just already in there in effect because you're working with radians rather than degrees. Okay? So let's try a couple more of those. Okay? And then there's some of those I've already, or I'm about to, pretty soon. I'm going to upload as soon as these lessons are up. I'm going to go ahead and I'm going to upload some classwork for you to work on with some practice problems. But here, so let's try this one. So let's try this. Let's say I've got a circle, right? And I happen to know I've got an angle here of 150 degrees, right? That's the angle. And let's say I know that the radius is 6 inches. Okay? So hopefully you can see that. I should have made that bigger. 150 degrees, and the radius is 6 inches. Okay? So what is the arc length? What is the physical linear distance from that point around in inches if you were to measure it somehow? Okay? Well, it's going to be, if we're using, since we give the angle in degrees, we're going to use the degree formula, okay, which is the angle R, or the angle theta, 150 divided by 360 times 2 pi r, or 2 pi times 6, right? So let's see. That angle reduces, as it happens, to 5 over 12 times 2 times 6 is 12, right? And 12 pi, actually, right? And then, oh, look at that. The 12s cancel out, and we get 5 pi inches, right? And if we change that to if we multiply that out, we get about 15.71 inches. That's how far that would be. Okay, let me see. Just assuming that I did that all correctly here. Let's see, 15 divided by 36. Yeah, 5 over 12, right? And then the 12s cancel out. Good. So there's that. That's an example there. Or what if here's another circle here, right? Not making my pictures very big, huh? What if I happen to know I'm thinking of an angle that is all the way over here? Okay? Which is more than 180 degrees. So let's say I happen to know that angle is 5 pi over 4. So the angle is 5 pi divided by 4. That's theta. And let's say we happen to know that the radius is equal to 9.2 yards. Okay, so we're using, notice the angle is given in radians. So this is radians. So we're going to use the radian formula. Okay, arc length. Okay, arc length is equal to 5 pi over 4 times 9.2, right? So nothing really cancels out there. So that is 5 times 9.2, it works out to be 46. So that's 46 pi over 4, which I guess could be 23 pi over 2 yards. All right? And then we can, 23 divided by 2 times pi is 36.1 yards. Okay? Now, we've got a few examples here, right, about that, and it's on the classwork, and you should go ahead and try those out before you start the homework. Now, when you get to the end, I'm going to summarize all of our formulas here. Okay? So now, the second kind of problem we want to be able to do involves calculating the sector area. So this was example 2, wasn't it? All right? Involves calculating the sector area. So if we've got, I'll use a fresh sheet of paper for that. So if I've got a circle with an angle like this, then this piece, this area, see that pi piece there? That's called a sector. And using the same kind of logic that we use to figure out the formulas for calculating the arc length, we can calculate the sector area, the area of that piece. And all we need to know is we need to know the radius, and we need to know theta, the angle inside the sector. Okay? If you're given the angle in degrees, your area for the sector area formula looks like this. It's theta over 360 times 2 pi, or rather pi r squared. Same formula, except instead of the circumference formula for circles, we use the area formula. If we're given the angle in radians, turns out the surface area is equal to 1/2 times theta times r squared. 1/2 theta r squared. Use this formula if you're given the angle in degrees for sector area. Use this formula if you're given the angle measure in radians for sector area. Okay? All right, so let's see how that goes. So let's say here we had 2 examples already. So let's do example 3. All right, let's say we've got a pi piece here. We've got a circle here. And let's say that it's that sector there where the angle is 135 degrees and the radius is 4 meters, let's say. So this is 4 meters, right? And then that's 135 degrees is the angle. So the sector area, the area of this piece out of the entire circle that I colored in, would be 135 over 360 times pi times 4 squared. And now we just go ahead and simplify that as much as we can. 135 divided by 360, right? So that's going to be 3 over 8 times pi times 16, right? And we can come, this works out neatly, so we can work with this fraction-wise, right? This is, that's 2, right? And so that's 2 times 3 is 6 pi over 1, or 6 pi meters. Okay, and 6 times 6 pi radians is about 18.8 square meters. Since it's area, we use square units, okay? So how about this one here? Let's say that we're given a circle, and I happen to know that it's, oopsie, sorry, bad picture there, but let's say that this is pi over 3 radians, right? And let's say that the radius is 10.6 inches, right? So what would be the area of this pi piece? Well, I gave you the angle in radians, so we're going to use the radian formula, right? So the surface area, the radian formula is 1/2 times theta times r squared, right? So that's going to be 1/2 times pi over 3 1/2 times pi over 3 times 10.6 quantity squared, right? So that's 10.6 squared is, is 112.36. Okay, divided by pi, 112.36 times pi divided by 6. And then we work that all the way out. And I'm getting 58.8 square inches. Okay, so that's kind of how that works. All right, there will be, like I say, go ahead and try out the practice problems on the classwork that you're going to see first. All right, but let me, on this last page here, I'm going to put this down, and it'll be in the video notes that I post, all 4 formulas. Okay, so there's 4 of them. Well, actually there's 6, because we had our converting formulas. So here are the formulas, the converting formulas. All right, we said that radians were equal to pi times the number of degrees. Oopsie. Sorry. Yeah, pi times the number of degrees over 180, right? And the number of degrees would be equal to 180 over pi times the number of radians. Those are the first 2 formulas we had. Then we had, okay, so this is going to be degrees, radians, arc length, sector area. Okay? Okay? The arc length, if you've got degrees, is theta divided by 360 times 2 pi r, right? If you've got radians, the arc length is just equal to r times theta. Okay? Okay? For surface area, the area is theta over 360 times pi r squared. And the area here is 1/2 theta times r squared. Will give you the sector area if you're in radians, right? And remember this, on our picture here, if we've got theta, and if we've got r, then here's going to be the arc length out here, and inside here that's the sector area. Okay? All right, very good. Okay, so any questions? We'll have a we'll probably have a homework review tomorrow should you need it. Okay? In any case, I'm going to go ahead. I'm going to stop this video now. Stay tuned for the video later on this afternoon or maybe tomorrow regarding our final that's coming up. Okay? Bye.